Here at Period 1 News, our anchors work day and night to bring you the best news possible. Here we have anchor Howie Stone on the way to work.
This is Howie Stone, Period 1 News from room 203. We're going to talk about simple harmonic motion today. Kicking it over to our pendulum reporter, Jack Mason.
Good morning. Today we're going to be talking about how things affect periods of pendulums. We're going to have masses, amplitude, and length. Mass and amplitude have zero effect on the period of a pendulum. Length, on the other hand, does. First off, we'll go to masses. Wow, isn't that interesting? Now, we have amplitude. This is how far back you pull the pendulum to let it swing. Now, you can only pull it back 10 degrees, or the equations get far too complicated for anyone but Isaac Crabtree to figure out. So, you can only go back to 10 degrees. So we're going to show you clips of 10 degrees, 8 degrees, and 6 degrees. Now, no matter how far you pull it back, this does not change the period.
It's cold! The thing we're going to look at is the relationship between the mass of the mass spring system and the period. So as the mass of the mass spring system increases, the period increases as well. So as the spring constant increases, the spring constant of the mass spring system increases, the period also increases. And there is also no correlation between the amplitude of the mass spring system and the period of the mass spring system.
Wasn't that cool? Now we're on to WABS.
This relationship we'll be looking at today is the difference between transverse and longitudinal waves. Transverse waves are similar to ocean waves. Longitudinal waves are similar to the waves for sound moving towards the target. As you will see ahead, the longitudinal waves move much faster. Wow, aren't those waves amazing? The next relationship we'll look at is the difference between fixed and free end reflections. The wave that hits the fixed end reflects back on the opposite side. The wave that hits the free end reflects back on the same side. constructive and destructive interference. This is when the waves are traveling from opposite directions and collide with each other. Constructive waves collide to make one big wave in the middle. Destructive waves collide to make no wave in the middle, because they cancel each other out. Let's take a look. We'll be looking at the relationship between the amplitude of transverse waves and the speed of those waves. When looking into it, we found that there's no effect on the amplitude and the speed of the waves.
Dude, where are you going?
Fantastic. Okay, next is the relationship between tension of a spring and the speed of that transverse wave. Each time we increased the tension, the time it took for the waves was roughly the same. This also means that increased tension yields a higher speed wave. Wow, what a day it's been. Our final relationship to look at is the effect of frequency on the wavelength. The more oscillations, the higher the frequency. So, when we increase the frequency or amount of waves there are, the waves are smaller. Therefore, higher frequency produces shorter wavelengths. And there you have it. We've taught you everything that a high school senior physics news team can teach you about waves. I hope you've learned as much as we have. Thank you, and have a good evening, Greenville. Back to you in the studio, Howie.
We've learned so much today. I know I have. This is Howie Stone saying good night.